Okay, so the topic of this particular session is statistics versus machine learning. So, without proceeding in art, we'll first look at what is statistics and what is machine learning. So, we generally have a, I, I will say, controversial statements that machine learning is statistics. Most of the statisticians would say that machine learning is statistics, but it is not so. Machine learning does use statistics, but it is not statistics. It is a part of artificial intelligence. So, if we see in terms of approach, statistics can be seen as more hypothesis driven and it is theory based, while machine learning can be seen as the data driven or the pattern recognition based on the pattern recognition. If we talk in terms about data, then statistics works usually on smaller data and carefully collected data, while machine learning works on larger data sets and it is mostly unstructured. Then, if we talk about in terms of model selection, then statistics work based on theories and assumptions, while machine learning works based on performance on training data. If we talk about interpretation, then statistics emphasizes on inference and understanding the relationships between the variables, while on the other hand, if we talk about machine learning, it emphasizes more on the predictive accuracy. So it do not talk about inference or what could be the relationship. What is the predictive accuracy? It emphasizes more on that. So now I hope you could have got the little bit idea of how machine learning differs from statistics. So now we'll start with our programming sessions. So for this particular session, we'll be using an iris dataset. So what iris dataset is? So we'll just go to simple help and type down the iris. So this is the data set which gives the measurements in centimeters of the variables sepal length and width and petal length and width respectively for 50 flowers from each of the three species of iris. So basically, uh, this is the data of the iris flower, 50 flowers, and these are divided into uh, three different species: Setosa, versicolor, virginica. So this data will be using. Let's see how the data looks like. So for this to work, we'll simply write iris. And once you write it down the iris and run the command, it will give you this particular data set. So this is the sepal length. So sepal length is basically the leafy part of a bud, mm, and petals are for flowers. So suppose we talk about red roses, then red are the petals, and the green, which is covering that particular flower or the petals, that part is called sepal. So the sepal length and the sepal width is given. Similarly, the petal length and petal width is given, and the species which it belongs to. So there are in totality 150 flowers, 50 in each category. So this is our iris data set. Now, if we look at it, uh, species, and there are the petal lengths and the sepal lengths. Okay. So is everyone able to load it in R? Okay, now we'll move to, okay, fine. Now, okay, now we'll move to let's check for the structure of this data set. So 150 observations having five variables, sepal length, it is numeric, sepal width, it is numeric again, then petal length, petal width same, and species is in form of factors. So this is the structure of iris data set. Now let us look at the summary of this particular data set. So let me just name it down, DAT, and I will use this DAT rather than writing iris again and again. So summary of our data is we have sepal length with its minimum as 4.3, mean as 5.8, maximum as 7.9, and so. Same for petal length, same for petal width and sepal width. In species, we have Setosa, which is 50 in number, versicolor, which is again 50, and similarly Virginica. So this is the brief summary of our data set. This is how our data looks like. Okay, now let's plot the sepal length versus the sepal width. So for that, what we have to do, we have done in our previous session. Can you plot down? Plot data is DAT dollar. Sepal length versus sepal width. So let's see how our data looks like. It is something like this. Okay. Then here we cannot identify which belongs to which category. So for that, basically which point belongs to which category. So for that, what we can do is color equals to DAT dollar species. Let's see. So it gives us something like this: black dots, then red, and then the green ones. So for this, for more better visualization, we can change these point values uh, to, let's say, 19. So something like this. So this is one species in black, another species in red, and another one in green. Okay. So this here we can see that this species with black in color is entirely different from these two. So some kind of a cluster is formed here. So we can easily identify that this belongs to certain other species if not colored as well. In that condition also, let's check upon the first, this one. So here also we can see that this is forming a certain kind of cluster and this whole is forming a certain kind of cluster, sorry. So this is how we can just on the basis of this is simple scatter plot. So on the basis of the simple scatter plot, we can identify that some kind of a cluster is forming. So there are certain observations of a particular relationship between the sepal length and the sepal width, and so. So this is how we can simply create this plot. Is everyone able to do it? If not, just Okay. Not able to get data. Uh, Sunita ma'am, you're opening. Just simply, you write it down iris and you will get the data. Let me know whether the problem is solved or not. Just type iris. Just let me check. Sunita ma'am, just write it down, library data sets, and then try typing iris again. Just write down the library data sets and iris. It should work. Okay, I'll get back to you. Any other participant facing any problem? Just let me know. Okay, fine. So now, as we can see here, that different clusters are formed. Now, suppose we want the mean sepal length for the and the mean sepal length for the species Virginica. Then, how to do that thing? So, first of all, we'll call this DAT species and then corresponding Virginica. Now, we will check that which values corresponds to Virginica. So for this, which is the function, which data species in not in square brackets, round brackets, we have to do it, is equals to the name Virginica. So here I got the positions of the data or the species for which or the flowers having the species as Virginica. So if I want to get the sepal length for the same, because this is basically the position. So we can, let's say within POS, a new variable position for position. I want to find sepal dot, let's say length, sepal length. Just a minute, we have it in there. It is sepal length, and for sepal length, we need those sepal lengths corresponding to Virginica, so corresponding to positions of this species having Virginica. So once we run this program, we get the sepal lengths corresponding to the Virginica. And as we wanted to find the mean of the same, so simply the mean function. So this is the mean sepal length of these 50 flowers having the species Virginica. So can you find it for others as well, for the other two or any one of the two? Is are these two lines clear to each and every person right here? So I hope you're able to do it for Setosa or versicolor as well. So similarly, we can get the summary or the data for specifically Virginica as well. The way we got the summary for our overall data. So let's check whether we can get it or not. So that dollar Virginica equals, we'll use the same positions, and this position will be used for DAT, comma, and these are the basically row number. So we'll just put it down row number position, and we want all the columns, so we won't name or we won't give the number here. So let's see whether it works or not. So see, we divided this data in only for the species Virginica. Now, similarly, we can get the summary of the data, the Virginica. So, the sepal length, minimum, median, mean, maximum, the sepal width, petal width, and the species Setosa versicolor 00 and Virginica is 50. So this is how we can get the summary of a particular species as well. We can check for the plots which we have done in the previous session. So let's check for DAT sepal length, and let's create a histogram for it. So this is the DAT dollar sepal length. Now, if we want to go it for this is for the whole data, but if we want to do it for only Virginica, then paste dollar sepal length. This is the histogram for the species, the sepal length for the species Virginica. So this is how you can create the histogram, the data. Similarly, if you want to bar plot, so simple table and table of DAT dollar species. So since each and every quantity was 50 only, so it number is reached to 50. Somebody wants to say something?
Hello, madam.
Yes, ma'am.
Can you please explain? Means we are getting the outputs, but when to use dollar and when to use the dot, when to use means any other symbol, underscore, like that. Dollar, I have understood that from the data that particular column, if you want to extract, then you are using the dollar symbol. But
Okay, fine.
specifically dot and underscore when we use, so that can you explain?
Okay, okay. I'll get that. Just a minute. Okay, see. Uh, when we started with this particular data, its name was something appearing as sepal dot length, sepal dot width. So the dot has come up from here only. We haven't given it any name. Basically, what R does is whenever it sees a space between the column names or row names, it will change it with the dot. The space will be changed with dot. The same thing was happening when the same thing was happening when we uh, read the file SMLR. It was having job uh, profile and role. So it was having dot 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 in between. Two dots were there, what I recall. So dot came from there. Now what about underscore? Underscore is I have given it as the variable name. You can only skip it, no issue in that. But it just because I cannot use space while writing a variable name. So just to separate the two words, I have used this underscore. That's all, nothing else. So this is how. This is why we used this underscore and dot. Dot was in the name only. That is why we used it. Okay. Now let's move
So,
on.
madam, say the dollar sign.
What about the dollar sign?
Huh.
Okay, okay. So dollar sign is basically used for extracting from data frames. Here, whenever you want to extract a certain particular column, so we will be using dollar sign here. So let's say if we write it about direct iris data set, iris dollar sample length. So it will give me all the 150 observations on sample length. That is how dollar is working here.
Okay, madam. Okay. Thank you. Thank you, madam.
Okay. Okay, now let's move on to the machine learning thing. So let here as we discussed that machine learning is all based upon pattern recognition. So for that, it will create a model, and that model will be created by a training data. And after creating that particular model, we will make predictions on the test data. Now, uh, how to do that? So, what we will do, we will start by splitting this data set. So, for that, what we are doing is let's start with train underscore positions. So, basically, from this very data only, we'll bifurcate this data into training data and the uh, test data. So for this, we will first find those positions which can be utilized as training data. So for that, what we will do, we will simply sample. Now sample is used when and why. Okay, so sample is here. This will generate a simple random sample. Let's say if I give it 1 to 100, let's not take up this right now. Okay, suppose I write down sample 1 to 10. So what it will give me? It will give me values 1, 7, 9, 10, 2, 4, 6, 8, 3, 5, 1. So it has utilized all the, it has exhausted all the numbers while getting this sample. Now if I want to have a sample of size, let's say 6, then it will give me 6 values selected randomly. If I run it again and again, it will give me different values. So this is simply taking at random, choosing at random 1 to 10, 6 values. Now what about if I want to get 11 values out of this? So it will say that cannot take a sample larger than the population, then replace equals to false. So basically, without in this position, this is simply giving us the simple random samples without replacement. If we want them to replace as well, so replace equals to true, and it will give us the desired size of 11 from 1 to 10 observations. So this is how sample works. So now in this train positions, what we will do, we will bifurcate this particular data set, 70% data set in training set, and 30% remaining will be the test data. So how you can do it? This is sample. We know that this is 1 to 50. So if we want to automate it, what we can type down? Number of rows, n row of our data. And what is our data? Iris or DAT. Let's see what it gives. So it gives us 150. So from 1 to 150, we have to generate the data with uh, 70% of the data we want to generate from this particular. So 70%, so 0.7 of our n. So what will it give us? 105 values will be stored in train POS. So see, let's say these are the values. So you all must be getting different values in your system because this is random in nature. And what about, so these are the positions has been selected. Now what we will do, we will convert this into the train data and the test data. So for train data, train underscore data, what we can get here is as DAT full data or the iris data in square brackets. Since these are the positions, so we want those position values. So DAT, and these are simply values of rows. So we will write down train underscore DOS and a comma. So when we will run this, we will obtain these values. So this is our train data, and once we do it with the for the test data, so test underscore data is equals to DAT. Now which values we want for test data which are not in train data? So for that we'll simply use minus train positions. So the rest of the positions will be stored here in the test data. So this is our test data. If anyone is having problem, just let me know at this point of time. Okay. Now, since in each of every one of us computers we are getting different values, so what we can do is we can fix the outcome so that we can check whether the values are matching up or not. So for that, whenever we take random samples from R, if we set the seed value, so set dot seed, let's say 1, 2, 3, then whenever you will run any code containing the random sample generation, it will generate the same sample. So let's see trend positions. So from 1450, 118 to 24. I have to run it. If I run it again, let's say if I run it again, this will give me a different value all again. But if I run it with this will give me the same value again. So we'll set it once, and since we are not running the same line of code again and again, so the positions will always be same for each and every one of us. So I hope it is clear up to this point. So now we'll move on forward. So we'll now train a linear regression model. So there are basically different ways or the different algorithms used in machine learning for pattern recognition. So here today uh, I will stick to linear regression models, as in your upcoming sessions you will be having advanced tools as well, and linear regression or the regression models will be discussed in detail as well. So today I'll be only be talking on linear regression model. So for this, what we will do is we will form a model of the sepal width based on the sepal length, petal length, and petal width. So how to do this? We'll just create a model. So model, just a minute. Model, and assign to this LM. LM is for linear models. So LM. Then we have the sepal length, sepal width, sepal dot width as sepal dot length as a function of plus sepal dot petal dot length plus sepal dot width. And since the sepal length, petal width, or the sepal width are the column names of the data, uh, our trained data, so we need to give or we need to specify data here also. So our data is a trained data. So let's see what it gives us. So our formula is given here. This is our data. So intercept for our model is 0.8470. Sepal length, the coefficient of sepal length is given, coefficient of petal length is given, and coefficient of petal width is given. So we can see that as sepal width is increasing, or the as sepal length will change by 1 unit, the sepal width will change by the value 0.65 0.74 if that remains the same, and same goes for petal length, it will decrease, and then petal width again positive. Right. So this is the model. Let's say name it model number 1. What we can do is we can create another model, model number 2, let's say. So based on this LM, so this is sepal, let's say only the function of sepal length and petal length. And again, we find it on train data. So this is 0.8117.
At the beginning of the tilde symbol, there we are giving the formula or standard formula that is the model we have
Sorry.
given linear equation that you have model 1 equal to some
Yes,
equation you
model
have.
we have. Yes, yes. I used it some equation. Yes.
So that equation you have formed or that is a standard equation somewhere
No, no, no.
else.
That is not a standard equation. Whenever you are modeling, there is
Uh-huh.
no standard equation kind of thing.
You
See,
are talking about linear. So what are the variables here? The width, length of the sepal and petal. Means there are
yeah,
four variables. Is it so?
see. As we have in linear models, in linear regressions, we have dependent variable and independent variable, right? So here we have the independent variables as sepal length, petal length, and the petal width. And our sepal width is depending on these three. That is why we created this model. If we think so that our sepal width is depending on the sepal length, and petal width, then we can go with the model number 1. If our sepal width is depending on the sepal length and the petal length only, then we can go with the model number 2.
But we are putting means there is no coefficient multiplying with the terms. We put plus sign. Sepal length plus petal width.
Okay. So this is
How
okay.
come the plus sign? There is no
Okay,
multiplier.
fine. Okay, got it. So the multipliers are obtained in the output. Here we are just saying that the sepal width is somewhat depending on the combination of sepal length, and petal width, but we don't know about that combination. So this LM, this LM is doing internally, it is finding out the coefficients for our model.
Okay, so plus sign is not the mathematical sum. It is just some symbol used for combination of those things.
Yeah, kind of. Yes, you can say that. Particle. Yes.
Right. Thank you.
Okay, fine.
But madam, model 1 is equal to sign. What is sign and model 1 sign? Symbol?
Yes, sir.
Model 1 is equal to or 1? Model 1, what is symbol? Symbol कौन सा है वो?
Symbol, this is a sign operator.
तो
I think you have missed a major part of the lectures.
yes.
So this is the assignment operator. You can use equal as well.
Okay. Okay, madam.
Yeah. Okay. So any other problem till this point? Fine. So here we have created two different models, model number 1 and model number 2. Now, what next? So now we'll try to make predictions on our test data. So how to do that? So we'll use predict for the same. So let's create prediction 1. This we are going it for the model number 1. predict. Here this is predict in stats package. So predict. We will give the name of the model. Then on which data it should be working. So new data equals to test data. Let's see whether it works or not. Model 1 is not found. Okay, let me run it again. Now it should work. So it gave me predictions based upon my test data. So this is for the sepal width. Now if I combine it with the actual value, uh, let's combine. So my test or data, sepal width, C point. So see, these 3.5, 3.2, these were the values uh, of values of the sepal width given in my test data. And what it predicted is 3.5 is predicted based upon my training data as 3.4, 2.9, 3.2 as 3.23, and so on, as you can see here. See, 4.4 is predicted as 3.88, 4.1 is 3.3, 3.0 is 2.6, and so on. Can you see it, the difference? Just create this one and check in your own laptops or desktops. So simply we have created here a model and model using the trained data. Then based on that particular model, we predicted the values based upon the test data. And what we predicted, since here our dependent variable is sepal width, so we are finding out the sepal width. Is it clear, the concept of training data and the test data?
Hello, madam.
Yes, sir.
Just one request, because I'm the mathematics person,
Yes.
and you are statistician. We are going to learn the R language.
Okay, fine.
So can you correlate that? Suppose we have linear regression, multiple or simple linear. So can you correlate the things?
Okay, so you want to basically understand what this model 1 is representing, right?
Yes, yes.
And
And
what are the
what is the A means or x1, suppose y is equal to x1 plus bx2, for example.
Okay, okay, okay,
Then
fine.
what the meaning of that A and x1 and how to correlate it?
Okay, okay, fine, fine.
Okay, thank you, madam.
Okay. So I'll just write down here. Let's say some x, some y. You can write down as this is a plus. Let's say some b product x and plus some, let's say, c product x. Let's basically go with this only. Okay. So what we usually, as we, I think we ended up the last session with the correlation part. So what correlation basically tells us is whether there is a relationship between the two or not. So if they are correlated, we say that there is a relationship, but how to measure that relationship? So Basically, the regression model studies the on an average relationship between the two variables. So now here, this very equation we have written y equals to a plus bx simply. So in any regression line equation, we have independent variables and the dependent variables. So here, independent variable is x and the dependent variable is y. Y. So let me give you an example. Let's say yield depends on raining in a particular region. Let's say only on raining right now. So this my x variable will be the amount of rain and y will be my yield.
Yes.
Is it fine?
Yes.
Okay. Suppose there is some measure of, let's say, quantity of fertilizers or organic fertilizers used. So let's say that is some value with some another variable, which is, let's say, z. So now my yield is depending on the amount of rain as well as the amount of fertilizer given
Okay.
in the
Got it.
particular soil. Okay. So now what my B and C are representing here. So suppose I talk about only X right now. So this will give me, as we can see that as we're a mathematics person, this is simply an equation of a line, right?
Yes. Yes.
So my A is slope, which we have mx plus c.
Yeah.
We have that c as the A here, and then b is the coefficient of my independent variable. Now what this coefficient means, it tells me that if there is a 1 unit change in my x, if there is a 1 unit change in my x, my y will change by b units.
Yeah.
Okay.
Yes.
So same is the thing here as well. Ki if I'm adding on another variables also, then keeping all others constant, for a 1 unit change, the change in the dependent variable will be the amount of the coefficient of that particular variable in which I changed by 1 unit.
Yeah. Yeah.
So is it clear by
Yes.
now?
Yes. 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 It is clear.
Okay, okay. So what here we are trying to do is we are trying to find the values of these A and B. We
Okay.
don't know the values of A and B. So for that we are utilizing this LM function, which is used for linear models. So here my Y is the sepal width and my X1, X2, X3 are the sepal length, petal width,
Okay. Okay. Correct, ma'am.
meaning three
Yes.
different independent
Independent.
variables.
Independent
Okay.
variables. Okay. Thank you, ma'am.
Yes.
Yes.
Okay.
Yes.
And now in this predict model, what we are doing is, uh, if in this particular model I have given all these values, the sepal length, petal width. Suppose I have these values because these are independent values. Suppose I have these values, then can I predict the value of sepal width? This is
Yes.
my task. So this is what we have done using this particular predict.
Okay. Thank you, ma'am. Thank you, ma'am. Yes. Got it.
Okay. Okay. So after using this predict, what we have done is we simply C bind the actual values in the test data of the sample width and the predicted ones. And we can see that some values are quite close to each other while the others are not. So here comes the question of whether the model is good or not. So whether this fitted model is good or not. So what machine learning does, it keeps on changing its model again and again to get the better accuracy. So for now, what we will do next is
Yes,
we
ma'am.
will
Yes.
ev-
Yes. Yes, ma'am.
we will evaluate the model.
Yes.
So how we will be evaluating the model? We will be finding the root mean squared error values, RMSE in short. So I'll just write it down here. So root mean square error. So as the name says, how will it be calculated? Root mean square error. So what is the error? Basically, the difference of the actual value with the predicted one. So we'll move from backwards to create the formula. So this is simply this test data tuple width minus this, sorry, predicted value minus this one and the same thing. We'll see on now square of the error. So square of the error, then mean of these values, and then the square root of the value. So S square root is given by SQRT in R. So this is how we can find out the value of root mean square error, which is 0.308719 for this particular model. Is the formula clear? Just the error, then the square of the error, then mean of the error, mean of the square of error, then square root of mean of the square of error. Simply. This is RMSE. So this RMSE is particularly for this value. Now, what if we change this value of set.seed? If I change the value of this set.seed, let's say 246, will my RMSE change? So yes, it does change. It gave me the value 3.07. Previously, it was 0.3008. So this value has increased. Now, so what we can do is, what if we run this program again and again and get the better value of this seed having the low value of RMSE? Are you getting my point? Okay, just let me know which model is better, the this one or the previous one. Mannat,
Error
there
could
are
be error could be less error is a better model.
less error is better. Yes, Mannat, there are other methods as well. We can check the quality of the model, but right now I am focusing on RMSE only. You can check for R squared values. If we talk about different models, you can go work with AIC models. But seeing each and every person here, I will just stick to RMSE because I'm not going into the depth of linear regression models in R. That will be taken up in your upcoming sessions. I'm here just to give you a basic idea about the training set, how to create it, test data, how to check and how to find, how to predict the values and so on. So this is how I'll stick to RFSE. Thank you. Okay. So now what to do? Have you heard about resampling? Have you people heard about resampling or bootstrapping? I think statistics persons must have heard about it. So what basically we can do is we can take again and again different kind of samples and find the particular value of set dot seed, uh, value of set dot seed having the least RMSE. So for that, we should have the idea of looping, because what we will be doing, we will be repeating the whole process again and again. Okay. And another thing which we can obtain is the somebody wants to say something. Okay. So we need to learn to create the function, how to create a function in R. Okay. So there are two things, functions and looping. Because the basic of this training and the test set is completed up to this point. But what I want you to learn is that how to get that minimum or the better model for your for prediction, basically in machine learning. Okay, so let's move to the functions. So as we know that whatever here we have used so many functions. We have used lm, we have used predict, we have used cbind, we have used mean, square root, sample, and many more. This bar plot, all these are functions, but these are inbuilt functions in R. What I am going to tell you is about the user defined functions in R. So what are user defined functions? So whatever I want to define in a function, I can create, basically I can create my own functions. So suppose we have a function for square, like power 2, or I think there is something. Oh, power. Do we have it? Suppose I want to create a function named square, which returns me with the value of the square of the given argument. So I'll simply write down the name of the function which I want to give it, which is square here. Then after equals, write down the function. Now function has its argument in the uh, round brackets. Then we'll start with the curly brackets and we define the argument. Now the argument, let's suppose this argument is some x. Now what this function should return me, x raised to power 2. Once I run this particular program, this will give me square of, let's say, 5. It gives me 25. If I say 50, it will give me 225 and so on. So here I have created a small user defined function of square in R. Similarly, we can create a function of cube. We can create any kind of function. Let's say we want to create a function of mean. So how can we create it? Let's say capital M function, argument given will be x. This time this x will be some kind of factor. So what we have to do, we have to sum x and divide it by the number of, or the length of x. So for the length of x, we have another function named length of x. Now this is the value. Let's say we have m and we supply it with 1 comma 2 comma 3, and it should give us the value 2. Correct? Okay, so can you create, let's say, a function which takes two arguments? So for two arguments, what we will do, we will write x comma y, right? So let's say we have, or this gives you function of x square plus y cube. Can you create a function which takes two arguments x and y and returns the value x square plus y cube? In the chat box, just write it down, the code. Sunita ma'am, kindly check this code whether it gives you the desired result or not. What I'm saying is it should give you x square plus y cube. Good one. Bankituchi. Am I pronouncing it correct? Okay, thank you. Anyone else? Others are not trying or they are not getting. Good deep also. Okay, fine. It's fine, it's fine. You should do it in an hour and there it should be completed. Okay, fine. So this is the basic idea of the function. Okay. Now, here what we want to do, what our basic goal here is that if we are dividing our data in the proportion of 70 to 30, that is 70% we have trained data and 30% we have test data. Then we need to find that particular value of seed, let's say in 2000 iterations, which gives us the, uh, or let's say in 1 to 2000, which gives us the best RMSE value. So for that, we need to create a function which gives us RMSE first of all. So for that, what we can do is here in set.seed, just in the beginning of the train underscore position, we can give it some value, let's say s. And here we will give the function, let's say this is RMSE. This function will give us the RMSE of the particular our particular body. Okay, so RMSE function, and this will be the function of what? This RMSE will be the function of S. We will feed the seed in this RMSE, and this will give us the RMSE value. So we'll generate such 2000 values and we'll check that particular value which will be having the minimum RMSE. Are you getting the point why we are feeding S in here? Okay, fine. So now this RMSE function should take what? Set.seed, then train positions, train data, test data, model 1. Model 2 can be excluded from this particular function, but I'm keeping it intact here. Then prediction, then this C-bind. C-bind is also not as much needed as I'm mostly concerned about the RMSE, but still I'm keeping it intact. And the last is RMSE. And here I'm just uh, ending this particular function. Now this how to get the value in return. See here, this was the first and the last argument. Suppose if let's say the function I asked you to create, let's capital F. Okay, one more thing. You have somebody has given capital F. So capital F by default is used for false in R. So whenever you are using the name of the variable, just type it down and simply run it. If something like this comes up, this means that it is already uh, assigned to some value in R or assigned some function in R. Let's say if I call upon data, which we usually talk about, if I run this is a predefined function in R. So I cannot use this or I should not use this. I can use this, but I should not use this, as whenever I will use the data in future in my that very program, that will be rewritten by the one which I have defined in my program. Okay. So let's say I defined it data 2. So now when I type the data, it won't give me the function. It will give me the value. So we should first check whether this particular whatever the name we are giving, whether it is in already in R or not. Like sometimes people give C while it is already for the combined function. So just keep that in mind. So let's say this is f1 equals to function. Arguments were xy. Now suppose I define a equals to x square. Then this will continue. So the function won't execute unless and until it executes the whole program under the curly braces. Then b is equals to x, not x, y. And lastly, I want in return, yeah, let's say simply a plus b, let's say. Let's see whether it gives me the function or not. The value f1 equals to um, 8. Sorry. There are two arguments. So, yes. So it gives me value 91. Now, what if I want, it was only one value. So, this one value is since printed here without storing it any other value. So, it is returning me a plus b. Now, what if I wanted the values of x square as well as y cube? That is, I wanted the values of a and b as well. So what I will do, I will combine a comma b, and let's say store it in k, some k. And in return, I ask for k. So let's see what it gives me again. So 64, 27, and 64 plus 27 is 91. So give me the square of 8, give me the square of 3, and cube of 3, sorry, and then added them up to 91. So this is how it works. So I can simply write return in our program, or if I do not, then also it will give me the value of RMSE. But to be specific that it should give me only the value of RMSE, I have written down the return. Now let's run this. So RMSE equals to function S. Now let's say I give this RMSE as 1. It will give me the value 0.3075. Let me give this value as so. For when the value, what is the value we are feeding in here is the value of seed. So if value of seed is 1, it is 0.3075311 is the RMSE. If it is 2, it is 0.3302934. Let us say if we go for 3, it is 0.3169. If we go for 4, it gives us 0.342, and so on. So we should select that one which is having the least RMSE. So how to do that? So for that, let's talk about the loops here. Since we have to run this again and again, that is why. So if you have done any other programming language, there is a for loop, there is a while loop. So what is the basic difference between these two loops? Whenever you have the fixed number of iterations, that is, you know that how many times that loop should execute, then you should go for the for loop. And whenever you are not you do not know basically that how many iterations should be performed, then you should go with the while. So both comes with the condition. In the for loop, the conditions are the number of iterations to be performed, while in the while loop, it if the certain condition is met, the loop should continue. If the condition do not met, then it will exit the loop. So we will talk about here for the for loop, as we know that we want to run this particular process 2000 times. So the number of iterations are fixed. So how to write a for loop? Let's say I want to store a value. I want to increase a certain vector, certain value by 1 each time the loop process. So how can I do this? Let's say I have a variable x having the value 8, and I want to add on the value 1 each time. So how can I do that? When I run this x, it gives me x value 1 is 8. So first value stored is 8. Now I want the second value to be stored as 9, then 10, and so on. So for that, what I can do is I will use the for loop. So for that, what I will be doing, for I in 1 to, let's say, 100 such values I want, for I 1 to 100. Basically, this is the condition for the for loop, that I will take value from 1 to 100. So first time when the loop runs, I will take the value 1. You can use any other variable here. You can write ITR, whatever it be. I have taken I. So I in 1 to 100. So ITR in 1 to 100, number of iterations. So for the how X should change with each iteration. So now as my uh, on the first execution, my ITR value will be 1. So I want to store it on the second number position. So for that, 1 plus 1 will be 2. So ITR plus 1 is equals to X plus 1. So whatever be the existing X value, 1 should be added in it. So let me, without running any for loop, let me take it for the only iteration number 1. So ITR is 1, and this is my X. So 8 and 9, second comes up here. Now on the second iteration, what will happen? ITR will go to 2. Now I want to store the variable at number 3. So for that, my ITR is 2. So 2 plus 1 is 3. So this will remain same. So X ITR plus 1 is fixed for all the iterations. But if I add X plus 1 here, what it will do? Since my length of the vector X is 2, so it will add 8 plus 1 and 9 plus 1, that is 9 and 10. It will give me X as 9 plus 10. So just we'll check it again. Okay, that is good to go. What happened here is, when ITR is 2, if simply we would have run X plus 1, so 9 plus 10 plus 10. What it has done here is, X ITR 1, it can store only one value, and it is now storing values more than 1, because X is of length 2. So what we have to do here is, we need to introduce the position here as well. So which position should be taken care of here? The ITR position. So just we'll remove it, and now we'll just uh, do it thoroughly. ITR when it is 1, then X2 position will be X1 plus 1, that is 8 plus 1. When ITR is 2, this X is 2 plus 1 is 3, X3 will be X2 plus 1. Now X2 is 9, 9 plus 1 is 10. So it should give me the results. Let's see whether it is giving me the result or not. So 8, 9, 10, 11 up to 108. Am I clear? Suppose I want to create a vector in a manner that it should keep on adding the square root of the previous value. So what can be done? XITR, this will remain same. Now in place of 1, it should give me XITR raised to power 1 by 2, or square root, we can say. Right now I am using 1 by 2. So let's see what it gives us. So 8 plus square root of 8, then this plus square root of this particular value, and so on. It keeps on adding. So we have just created a simple for loop here. Does anyone have any issue in creating this particular mini program? What do you want me to repeat, Bankit Dorji? Is this for loop clear to everyone? If anyone is having issue, just let me know. Just raise your hand. Sometimes I don't get to the chats. Okay, there were 50 or more warnings. See the first 50. My values are coming any. I got this error one. Okay. Can you copy down your code which you have run and creating problem? Both of you. Neetaji, which code you want me to share? All the codes are write down here in my presentation. Okay, let me check what is the problem. It's working completely fine. Bankit Dojit is working completely fine. Follow me, Paul. And we have the code. You were facing certain issues. NAs were coming. Okay, meanwhile, whenever I talk to participant, others can try other things as well in this particular coding. Okay, why did you use C here? Follow me. It should not be C here, no? They should be X. Then it should work. Okay. And why this ITR plus 1? Which value uh, this ITR1, if you write it down here, it is not created and you are using it. That is why it is creating problem. Just remove this plus 1 and then just run it. This will work completely fine. Just these are the values. Okay, fine. So this was the basic for loop. Now how to use this for loop for getting these value from the function. Can you people try? Just what we want to do is in place of this ITR. or you can keep ITR intact. This should be 1 to 1000, and in place of this, it should give us RMSE. Okay, that could be difficult. Let's see if someone who's good in R can answer. For others, I will do. Can anyone run this for loop for RMSE? Okay, so we'll start. So let's see. We have or let's say I in 1 2, or we have S. Okay, S in 1 to 2000, and we want to find RMSE. Yes. Now, if we simply run this program, this won't give us any result. Okay. So what we need to do is we need to store these RMSE values in certain variable. So as we know that each RMSE will give us one value, so we will be having 2000 values, and that can be stored in a vector. So we will define a vector, let's say RES for result equals to, we could have simply stored RES with the on the asset position, the value RMSES. So if I run it without declaring the variable, once I run it, this will give me that object RES not found, because R do not know the nature of RES. Okay, so RES, if I define it as an empty vector, so this will give me null. So it is an empty vector. Once I run it, it will fill this empty vector with the values of RMSES. So now when I run this, I will get these values. So these are the 1000 values of RMSE, and using these 2000 values, now I want to find the minimum of these RES values. So this is 0.21404422. Now this corresponds to which value? So again, I would like to use which command here, which. So basically we need to check which RES is equals to minimum of RES. So which RES equals, since it is a logical argument, so wherever it is true, that which corresponding that true will be uh, the value which we wanted. So when we run this, we'll obtain it as 32. So our S value is 32, for which it gives us the minimum RMSE. Is it clear to all? Okay, fine. So this is one of the basic criteria to get uh, the variable or to get the uh, model having the least RMSE. What else we could have done? As we have used model 2, we could have defined various different models and we would have compared the values over it. So let's say we used model 2. Okay. So for model 2, we just predicted for model 1. Let's say we predicted for model 2 as well in the same function. We'll write it with for model number 2. We will predict the value. Then it is not needed. We need the RMSE values. So for RMSE, this is, let's say, RMSE 1 for the model number 1, and for RMSE 2, this is for model number, okay. And I would ask R to return both the values, RMSE 1 as well as RMSE. This should be in the vector form. So now when I run this code, RMSE, just RMSE, it will run the whole code up to this point. Then when I run this and I ask R to just, let's say, RMSE 1, 2, 3. So for 1, 2, 3, it gives me values 0.2657 at 0.2963087. So these are the two values which it gives me for the same. And so here we can see that our model number 1 is better. Let's check for other value as well. It says 4, 2, 3. Again, my model 1 is better than model number 2. So this is how also we can compare which model is better. We could have created other models as well. Let's say sepal width is only depending upon sepal length, like this. So till this point, any problem in anything? If you want to discuss anything in all the 3 lectures, you can ask, as we are remaining 20. Yeah, sure, I will share it. This whole code is created for you only, so no problem in sharing from my side. I will share both the codes. I hope your code, your email is in the list. Yes, I'll mail all of you. Those who joined late this workshop can, I will mail it to Savitri ma'am. She will mail it to you. Okay. So I think I can give a brief, quick repeat to whatever we have discussed today. Yes, I will share the R code, ma'am. I will share it. No issue. Do you people want me to give a revision, or you want me to discuss it further? We'll just take up another model and we'll discuss it again. What do you want me to do? Revision. Only one participant replied. What about others? Why I'm saying so for the repetition, because I think it will be helpful for you to do in 3 days, since some people join it uh, late. So I think I can do that. Okay, so we'll go with just a quick revision, whatever we have discussed today. So we first learned about the setting of working directory. It was supposed to be the first, but yes, now I can say that it is the first thing to do. So set the working directory, and I hope most of the participants would have done this. So this is simply write down the path wherever you want to save your programs in, and just keep the path in the double inverted commas. Then we talked about R as calculator. So we did some basic operations in R: 2 plus 3, 4 minus 2, 4 product 2, 4 division 2, and so on. And it gave us the certain results as well. Then we talked about that it follows the BODMAS rule, that if you give a 2 plus 3 product 2, it will give you the result as 3 plus 3 product 2, which is 6 plus 2, 8. Similarly, if you want to first add on 2 and 3 and then product 2, we can use the brackets. Then we describe the numerical variable. We start with the different types of variables in R. So first is the numeric data type or the variable. So we described here age and assigned it as 25. This is simply an assignment operator used here. Then we used mode. Mode is used to get the uh, data structure of your particular variable. So this is numeric in nature. Then we stored statistics in subject as the character variable. So character variables are always written in double inverted commas. So this is a character variable is created right here. Then we go for logical variables, which is s underscore student, which is true. So true and false will be stored as up here. Then I introduce you to factor variables, which was in gender we stored factor variables. Basically, gender is a factor variable. So with levels male and female. Then we assign date variable using this date. Then we studied data structures in R. So there are various data structures like vector. So for vector, we can simply use combined and write down the name of the variables. Then we did some operations on these vectors. So we created two different vectors x and y and added them. Then we introduced another vector with length 3, and then we added x plus z. So it created an error since longer object length is not multiple of shorter object length. So basically there is a difference in length, and this length is not a multiple of length of z. So that is why it is not added to it. Once the length of the two vectors adding um, are in multiple of each other, then the addition can be performed. So when it was this gave us that x plus b is 7, 9, 14, and 6. Then we introduced matrix. So for matrix, we simply gave some vectors and then number of rows and columns. Usually it well, by default it stores the values um, column wise, but by using by row equals to true, we can store it in the form of by row wise the data. Okay. Then this was for 4 and 5 we wanted to create. Then how to define an array? We can use array and specify the various dimension. This was the array, and we can simply run my array, and it was three-dimensional storage. Then we use list. So We introduced list as storing the variable having different data types. So here 1 and 2 are numeric data type and A and B are character ones. So list simply stores their nature or their mode, keep it their mode intact. Then comes the data frames. For data frames, we use data.frame. We simply run this and it gives us this variable. So data frame does the same thing. It keep intact the nature of the values given to it. Then how to assess elements from the vector. We use square brackets for vector. We use uh, square brackets with single value for vector. Then square brackets with the column row number and the column number for the matrix. And for array, we have three different values: row number, column number, and the height. So this will give us the particular position of the element. If we want to find only the, let's say, um, third dimension to be 2 and others not fixed, then this will give you an simple, just this will give you simply a matrix. And how to assess elements from list, double square bracket 1, 2, 3, 4, whatever it be. Then similarly d1. So this was, since it is in the same looks same as matrix, so we tried to assess it in the manner of matrix only. So it worked in the same manner. But we can also do it with dollar sign, but it will extract the whole column. So d1 dollar name, so it extracted the whole column. Then again, okay, then we tried to import the data in R, and we imported the data smlrd01. Then we set working directory. Okay, then there was some mode of data file age. We extracted age, then find the minimum, maximum, mean, and median of the age. Then summary of age. Then we took subject smlr, so it gave us subjects. Yes, it is, should not, yes, gives us different subjects. Then we find the unique out of them. Then we plotted bar plot. Then we stored all these scores in their respective variables from smlr only. Then we used scores and finally bind this mean score. So I think there is no need to go into the detail of this. This is basic mean, and we use the C bind. C bind is basically for column binding. So whenever your variables are having the same length, then they can be combined by column, as well as they can be combined in rows as well. For row bind, we have R bind here. So in place of C, you will write R bind, R only. So R bind for row binding. Then we have plotted RF scores for scatter plot. Then this is for line and point plot both. Then we plotted pie chart for the subjects. Then we plotted histogram. Then we find correlation values. Then we find we plotted to check whether they were linear in nature or not. Okay, so somebody asked me to check the linearity. So uh, there are various tests for it. So one of them is Durbin-Watson test. So you can search for it and you can check how to apply it for linearity checks. Or I think it should be, or it will be done in your upcoming sessions. So then comes his correlation test we applied here, which gave us the test statistic value, p value, the confidence intervals, and the correlation value. Then to check the structure of the SMLR, we use the function str. Then we learned how to export files from R in CSV format or in text format. So write.csv for CSV files, write.table can be used both for text and CSV. So we used it here, and then simply we started with this machine learning. We started with iris data, then we use str to get the structure of this particular iris data set. We plotted, we check for the summary of this data, then we plotted the values on the petal length versus the petal width. Then we try to find the positions of the data where the species were having value as Virginica, and used it to find the mean of the sepal length corresponding to the species Virginica. So it was 6.588. Then we used that Virginica to get the entire data of species Virginica, or basically extracting it from the main data. Then we summarize the data, we draw histograms and bar plots, then we tried, we understood what do we mean by sample or how to find the, this is basically random sampling it is performing. So how to do it. Then we created a simple train data, test data, how to create it. I think at this position, everyone was here. We have done enough discussion over this thing. Then we created the function RMSC, and then simply iterated it again and again. So we got 2000 values, and for the S for which it was minimum. Okay, got it. So now since we are returning two different values, so the same program won't run again. So suppose we were only obtaining this particular value to X, so this will run again. So let's suppose RMSC will run this. It will give us RMSC 1, and this will should run now without creating any problem. So it was 32 value. So this is how we tried to learn how statistics can be used for machine learning in R. So I hope worked well for you this session. So over to the organizers. So I will share the code with the participants of whom I'm having the email IDs. And for rest of the participants who join later on, Savitri ma'am will host